Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So I hope you all in a good health and also good spirit. So this is Geotechnics Laboratory for Soil Compaction, and before I go further, I would like to share with you a video on the soil compaction activities that has been done in the Lake Townsend Dam. So this is time lapse for an concrete dam, but it involves a lot of machinery to compact nearby soil. So in order that we have a systematic dam. So as you can see, there's a lot of roller, also excavator, and cut and fill also occurs in there. And it is important to have a very good soil compaction so we can have an increased unit weight of the soil, so it could sustain and could provide a good dam. I am Dr. Siti Nora Fida binti Yusof, and for this semester you will be facilitated by me in order for you to complete the G1 test soil compaction. Okay, as I mentioned just now, the soil of any construction field need to be compacted due to the purpose to increase their unit weight, And I hope you still remember from your soil mechanics class previous year that we do compaction to densify the soil, so the soil particles will move to densely packed position with the addition of water and by remove the air. And those compaction requires for mechanical energy. So in field we can use a roller and so on. In the laboratory we use a standard proctor or modified proctor. And the degree of compaction is measured in terms of dry unit weight, or we also have another type of measurement, dry density. Okay, so just now I show you the time slip for the construction of Lake Townsend Dam. If you're interested to know the full version of the video, you can go to this link. Okay, for the laboratory purpose, so we have standard proctor and also modified proctor. So for your courses, we covers the standard proctor and we follows the BS standard, British standard of 137777. And I hope you still remember the mole volume of the standard proctor. It is equivalent to 1000 centimeter cube, and it has a hammer which we usually want to have a free fall of hammer. It's not a pushing the hammer, but free fall of the hammer. And the weight is 2.5 kilogram with a fall distance of 300 millimeter. However, during this demonstration, I will show you an automatic standard proctor that we recently have in our laboratory. Okay, for every blows, I hope you still remember there will be about 25 to 27 blows with the number of layers of soil will be about 3 layers. And the soil sample that prepared to carry out the compaction must passing the sieve number 4, means bigger than clay, passing sieve number 4 or smaller than sand. Okay, so the soil will be compacted, and during the compaction we use a mold, and this mold is attached to the base plate, and also it has an extension, or I would call that as a collar. And for the soil sample, we have to varying the amount of the water, so we can have about 5 to 4 different soil samples, and we do the compaction. Okay, this is the schematic diagram of the mold with a volume of 1000 centimeter cube per meter. So this is what I call as a collar or extension, and this is a base plate. So the mold is attached to the plate, and this is the hammer that we use, and the weight of hammer is about 2.5 kilogram, and the drop is about 300 millimeter. Okay, usually in laboratory, we attach the collar into the mold, but before attaching the collar, we have to wet first the mold with the base only, because later we want to use this weight as a wet soil weight. And if you can see, we have a casing to provide to as a workplace, and we also have a hammer here, and some other tools to assist our compaction process in laboratory. Okay, so if you can see also here, I'm adding the figure of a container. So small container later will need to be used to collect a small amount of soil that has been compacted. After the compaction process, we have to collect small amount of soil from the middle of the compacted layer, so we can measure the moisture content. So this is roughly the testing procedure that include during the process. So we have to mix thoroughly the soil sample with a certain amount of water. So this is one sample. This is one sample. So we might have 4 to 5 different water samples. So we can get 4 to 5 different samples. So for one soil sample, we divide the soil that mixed thoroughly with the water into 3 different soil layer. So 3 different portion. So it is filled up into the mold one by one. So later I will try to show you the video of the soil compaction process, but this is the automatic soil compaction, the Proctor test. So the soil that already filled up the mold will be compacted 25 blows with a 300 millimeter free fall of the hammer. And after the compaction process finish, we have to pull out the collar and trim the soil, so we can have a weight of wet soil sample. And after that, because we want to take the soil sample from the middle of the soil compaction, we need to push the soil comes out from the mold by using the rig as a support, and we push hardly and push the soil out. And we cut the soil body, take a small amount of soil, and weight the soil with a container before and after the drying process. And usually the drying process will take about 24 hours. And this result will become their moisture content. Initially, we already mix the soil with the water, but that is not a moisture content. The final results from the compaction is the moisture content. So after finish doing for first sample, change the water composition value and do again for different soil sample. Okay, so once we got the test results, so we have to analyze. During the testing, we managed to take the weight of wet soil sample, weight of the compacted soil in the mold. So this is wet soil sample. And divide with the volume 1000 centimeter cube, so we get the bulk unit weight. And from the results of moisture content, we can get the dry density. So what we have to do, determine all the moisture content, and define for the maximum dry density or dry unit weight. Plot the results of dry unit weight and also the moisture content, and get the optimum moisture content and also the maximum dry density or maximum dry unit weight from the graph, not from the calculation, from the graph. So if you could see here, this is graph of compaction for 5 testing. 1 sample, 2, 3, 4, and 5, the 5th one. And you can note also this is a zero air void curve, zero air void curve. And if you can see here, at the point, critical point here, the zero air void is superimposed with the results of the compaction. So it's still accepted. But if you plotting the zero air void inside the curve, so it will be a wrong wrong results. So you have to comment why it is happened. I'm sorry. Okay, it's okay. So next. Okay. I'll try to draw what if the zero avoid is inside. So if the zero avoid is inside the curve, so it is wrong. So you can give your opinion why it is happened. So usually because of the faulty during the compaction. Okay, that's all for the slide, but I would like to show the video and also the data. Okay, so this is example of your data, soil compaction data. So I already given to you the weight of sample, initial one, 2 kilogram, initial water content, the module of the mass of the module without soil, mass of the mold with the soil which has been compacted, this one. So you have 5 different sets of results. So how to get the mass of wet soil? So you just minus this one, 7.45 to the mass of mole, so you can get this one. And remember the volume of mole is 1000 centimeter cube, so you can change to meter cube and you can easily obtain the bulk density. And for the moisture content, so moisture content, the weight of the soil that taken from the middle of the compacted soil with the container, this is the mass. And after drying 24 hours, this is the dry soil mass with the container. So you can get the mass of water and mass of the dry soil, and easily you can get the moisture content. If you forgot how to calculate the moisture content, you can go back to your soil mechanics book and try to calculate. And lastly, you can easily calculate the dry density. So this is how the compaction is carried out. So you can see the automatic hammer is free fall for about 25 blows per layer. So we have to do that for every 3 layers, for all 3 different layers. Okay, and this is how we want to push the soil sample out from the mold, because we want to take the middle part of the soil to, I can show you again. If we want to take the middle part of the soil to take the moisture content. If you can see, your seniors already done a few times of the different soil samples. So she is already cutting and take the internal soil sample to measure its soil moisture content. So we do this, pushing out the soil sample, and take some of the sample at the end of every 1 sample of compaction. Okay, so I think that's all from me. Good luck and all the best. If we can have sometimes to see you online, so we can do so. For any questions, please don't hesitate to contact me at 013-754-6450 or to my email snorafida@utm.my. Assalamualaikum. See you again. Bye.